end behavior. End behavior is what is happening at the end of each linear function on the graph. So on this graph, the end behavior would be happening right here and right here. So to solve for the end behavior, we have to find the domain and the range. To solve the domain on this, you would just look at the end of the line. So the domain for this would be negative infinity, because it's constantly moving left on the x-axis, and positive infinity means it's constantly moving right on the x-axis. And for range, you do the same thing, except for up and down. So it is constantly moving down on the x-axis, on the y-axis, and it's constantly moving up on the y-axis as well. So we would have the negative infinity and infinity for our range as well. And end behavior will always have as x approaches, which is what this line means, and then we plug in our first domain value. So negative infinity, y approaches negative infinity as well. It means we plug in our first y value. And that's because right here, as x is approaching negative infinity, which we continue on that way, y is also approaching negative infinity by going constantly down. And then the second equation is just looking at the other end of the line. So as x approaches infinity, which is our second domain value, y approaches infinity. Because for the same reason, y is constantly going up, and x is constantly going to the right. So that is how you solve for end behavior. This next problem is a little bit more difficult than the last one, because it is not a line but a segment. And so we still need to find our domain and our range. So our domain would be negative 4, means that is the furthest left on the graph it goes. And then our the furthest right on the graph it goes is 3, positive 3. So our domain for this equation would be negative 4 and positive 3. Our range would be negative 3, means that's the furthest down it goes, and 2, means that is the furthest up it goes. And so our end behavior, as always, you have as x approaches, and then first domain value, negative 4, y approaches our first y value, or range value, and then on the other side of the graph you have as x approaches 3, so x is approaching 3 right here, y is approaching 2, because they meet at that point. And a common error for people to have on these end behavior problems is they switch up their domain and their range values. So like they could have like 2 in the place of the negative 4, and that would just make this not, like it would just make it incorrect according to the line or the segment. This next problem I'm going to do live, means it's a little bit more difficult. And so first we have to find our domain and our range. So our domain and our range. And so, see, the furthest left this graph goes is negative 5, means that's where the point is. So our first domain value would be negative 5. And we put a bracket on it because as the solid dot, it is attainable. So it is on the line, which would be the line of best fit here. So it would be on the line, so negative 5, and then our furthest right it goes is 4 right here. So we put 4 as our second value, and it is also attainable. And our range would be up and down, so the furthest down it goes, or negative, is negative 4 right here. Or, sorry, negative 5. And so we put negative 5 again. And the furthest positive it goes is positive 5. So then we put 5. And since it's an open dot, it is not attainable. So that's a parentheses. And our end behavior, as always, it's as x approaches, and then we would put our first domain value, so negative 5, comma, y approaches, and then we put our first y value, negative 5. Because as x approaches negative 5, so that's going this direction, y approaches negative 5, so it's basically just saying like right here. They just kind of intersect at the same point. And then it would also, and then on the other side of the graph, it would be as x approaches, and then our second domain value, so positive 4, y approaches our second range value, which is positive 5. And that is basically all you need to do for end behavior. It's pretty simple. And yeah, I hope this helped. And a common error that could happen here is people could think, like, they could just confuse and get their x's and y's wrong, or their domain and range. So they could think like, oh, -5 and -2 would be my domain. And that is incorrect because the graph goes all the way across and it includes everything. We're not just including one of these parabolas. And to study, I would just keep doing these problems, because you just gotta understand that it includes the entire graph, not just one segment or line.